Okay, so today, Year 10, we're going to start to have a look at probability trees without replacement. So you've done some probability trees already last week, and now we're going to look at questions where you don't replace the thing you're putting in. So this is the situation. We have got in a bag 3 red balls and 4 blue ones. And I'm just going to talk you through this diagram here and what's going on. Let me just switch my pointer so you can see. So to start with, here are the 3 blue ones. Ignore that, can't count. Here are the 4 blue ones and 3 red ones. Okay? So at the beginning of the question, the probability of taking a red one is 3 out of 7. The probability of taking a blue one is 4 out of 7. Okay? But then, if I've taken a red one out, so how many red ones are left? There's only 2 red ones left, but there's still 4 blue ones here. So now this time round, the probability of taking a red one is 2, because there's only 2 red ones, out of 6. The probability of taking a blue one, well, there's 1, 2, 3, 4, there's 4 blue ones, 4 out of 6. Now here, this is not going to be the same as it was here. These are going to be different. Let's see why. So this option is saying, well, I chose a blue one first of all. So I took out a blue one. So left behind there's still 3 red ones. So the probability of taking a red is 3 out of 6. And here, the probability of taking a blue, well, there's still 3 blue ones left. So 3 out of 6, like that. So then, what would the probability of taking a red and another red be? That would be 3/7 times 2/6, which is 6/42. What would the probability of taking a red and then a blue be? That would be 3/7 times 4/6, which is 12/42. What would the probability of taking a blue and then a red be? That would be 4/7 times 3/6, which is 12/42. And then finally, what would the probability of taking a blue and then a blue be? That would be 4/7 times 3/6, which is also 12/42. So the main thing that's going to be different today is that these probabilities here will not be the same as these probabilities here. We'll look at another couple of examples now to hopefully help make some more sense of that. Okay, so then first full example of a question that looks like this. A bag contains 7 red balls, fine, and 3 green ones, fine. 2 balls are taken from the bag. So what's important is they're taking one, they're not putting it back in the bag, they're just taking one, and then they're taking a second one. So showing this on a probability tree. This is the first pick, and this is the second pick. Now on my first pick, I could get a red or a green, and on my second pick, red, green, red, green. So far, fine. After that, it's got 7 and 3, so that's a total of 10 at the beginning. So at the beginning, 7 are red and 3 are green. That should be fun. But then, I've taken out a red ball. I've taken out a red ball, which means in total, there's only 9 left. And because I've taken out a red one, there's only 6 red balls left, but there's still 3 green ones left. Down here, this is saying I've taken out a green ball. So there were 10, there's now only 9. There were 3 green ones, so now there's only 2 green ones, but there's still 7 red ones. And now we can just write out a list of all of our options. So my options are, I could get red, red. I could get red then green. I could get green then red, or I could get green then green. Oh, let me just rewrite that. And then let's just fill these in with some probabilities. So the probability of red then red is 7/10 times 6/9, which is 42/90. The probability of red then green is 7/10 times 3/9, which is 21/90. Green and then red is 3/10 times 7/9, which is 21/90. And then green is 3/10 times 2/9. Oh, again, about that. Which is 6/90. Lovely. Now let's actually go back to the question and answer parts A, part B, and part C. So part A says, what's the probability they're both red? Oh, we've worked that already. It's 42/90. So A is 42/90, and that simplifies because they both divide by 6 to 7/15. Part B, hopefully also nice and straightforward. Both green, we worked out already, is 6/90, and that simplifies to 1/15. Part C may be a tiny bit harder because it says 1 red and 1 green. Now to get 1 red and 1 green, I can either go red then green, or I can go green then red. Now when it's this or this, two things or, you add them together. So we add those two different options together, which gives a final answer of 42/90. Then that simplifies down to 7/15. Okay, and that's our final answer there. Now, if you're happy with that, just get started straight away with the work year 10. If you'd like to watch another example just to clarify what you should be doing, have a go at that now. Okay, so final example year 10. If you're quite happy, just get started with the work. But if you're not happy, maybe watch this example here, which should help to re-explain things. So George got a bag of marbles, 6 red and 4 white. Lovely. He takes a marble out at random. Without replacement, he takes out another marble. So we're going to start by drawing out my tree diagram. This is the first marble. This is the second marble. Okay. So then we've got red and then white. So let's label this bit here with red, this bit here with white. Then this would be red, this would be white, this would be red, this would be white. So to start off with, what's the probability at the moment of taking out a red marble? That is going to be 6 out of 10. There's 10 marbles in total. Taking out a white marble is going to be 4 out of 10. Then, after that, I've taken out a marble. So how many marbles are left in the bag? 9. So all of these second pick probabilities are all out of 9. Then here, I had 6 red marbles, but I've pulled out a red marble on my first pick. So left behind are 5 red marbles. There are still 4 white marbles in the bag. In terms of the other option, so the other option is that I pulled out a white marble first, in which case there are still 6 red marbles in the bag, but the number of white marbles, because I've taken out 1, has reduced to 3. And then I would encourage you just to write out all of your different options. So we could have the probability of red, red, the probability of red, then white, the probability, sorry, let me swap that out. The probability of white, then red, or the probability of white, then white. Okay, so then if we wanted red then red, it would be 6/10 times 5/9, which is 30/90. Red then white would be 6/10 times 4/9, which is 24/90. White then red, 4/10, 6/9, 24 over 90. And in white, then white would be 4 over 10 times 3 over 9, which is 12 over 90. And the question I'm going to ask is the probability that they are both the same colour. So the question we are asking now is, what is the probability that he pulls out 2 marbles which are both the same colour? So there's 2 different ways that could happen. He could pull out red and then red, or white and then white. Okay? And then because it's red and red, or white and white, we add them together. So 30 over 90 is 12 over 90. It's 42 over 90, which simplifies down to 7/15. Okay? And that's it in terms of probability trees without replacement. Have a go now at the questions on the sheet. I've given some guidance as for what ones you should do if you're more and less confident and so on. As ever, please make sure you're marking your work and letting me know if you've got any questions about any of that.